By the time of Copernicus's observations, Mars and the Earth had been passing each other in their respective orbits for some 4.5 billion years. Time enough for the two planets to have evolved into very different worlds. One warm, wet, and oxygen-rich. The other cold, dry, and oxygen-depleted. Yet it's now believed that the differences weren't always so stark. Scientists today think that Mars was once warm enough for large amounts of liquid water to flow across its surface.
When we look at Mars today in our best satellite images, they tell us the same message we heard with the first missions to Mars, and that is that there's no liquid water on the planet today. But there's virtually incontrovertible evidence that there was water there in the past. Everybody knows that when water flows through any sort of dirt, there are characteristic structures that are a function of that water running through. And when we look at the pictures of Mars, the satellite images, we see very similar structures leading us to the absolute conclusion that Mars was once far warmer and wetter than it is now.
Mars, of course, is a harsh desert today. So what could have happened? What cosmic processes could have brought about such a dramatic transformation of the fourth planet from the Sun? The story begins with the origin of the solar system. Somewhere in the range of 4.5 billion years ago, our solar system sprang from a supernova, a stellar explosion emitting a swirling mass of molecular particles and gases. This swirling mass, or nebula, began to cool, and as it did, it condensed and separated into rings of particles. These particles began to accrete, or gradually clump together to form planets. The accretion process creates heat, and heavier particles sink to the center of the accumulating mass. So Mars eventually formed a molten iron core. This churning molten core generated a powerful magnetic field. The field projected outward, surrounding Mars like a protective shield, blocking harmful emissions from the Sun.
You have this constant pressure from the Sun, which we call the solar wind. The solar wind is made up of protons, electrons, cosmic rays, all of these kinds of charged particles that could ionize the atmosphere, as we call sputter it away.
But eventually, Mars lost its protective shield and most of its atmosphere. The moment the accretion process ended, the planet began to cool.
The iron core was no longer able to generate this magnetic field, and then the solar wind started pounding the surface of Mars. That's a scenario that a lot of people believe.
The loss of atmosphere stripped the Martian surface of warmth and pressure. And since water needs both warmth and pressure to remain in liquid form, water is no longer stable on the Martian surface.
You put a pan of water out on Mars, it's going to evaporate very fast and try to freeze at the same time. One or the other will win out, but you won't have a nice liquid pan of water.
That's not to say, however, that there is no water on the planet at all. While liquid water is no longer stable on Mars, frozen water, ice, is a different story. And evidence suggests that still today, tons of water ice might lie just below the Martian polar caps. Locked within that ice might just be the holy grail of space exploration. They are visible through simple telescopes on Earth. And they are unquestionably the first planetary features noticeable during an approach to Mars through space. The Martian polar caps. Mysterious snowy white ice swirls sheathing the top and bottom of the red planet.
It's actually what we call dry ice, frozen carbon dioxide. The atmosphere is very thin and it's nearly all carbon dioxide. So when it gets very cold, what condenses out is carbon dioxide snow, carbon dioxide ice.
But while the white caps are certainly a colorful planetary feature, it's not the frozen concentrations of CO2 themselves that are of most interest to scientists. It's what's thought to be hidden beneath the polar caps that could have massive significance. Lurking just below the topsoil may be millions of tons of frozen water. Water ice, hidden from view, appears to radiate out hundreds of miles in all directions from the poles. And leading scientists think it could be the residue of once vast oceans.
Likely the water is now frozen in a kind of permafrost beneath the surface. But maybe there are pressures and temperatures in various areas of Mars that have liquefied the ice and created perhaps aquifers.
We can see craters, an impact has happened. Asteroid has hit Mars, blown out a lot of stuff. It doesn't blow out dry powder like on the moon and make rays and rubble. It throws out kind of a muddy slurry of stuff. So the conclusion is that you're actually impacting into ice like northern Canada, permafrost layers, tundra kind of stuff.
Orbiting spacecraft have picked up strong indicators for the existence of water ice at the Martian poles. Remote measurements of soil composition have detected high levels of hydrogen. Water, of course, is 1 part oxygen and 2